Hi, Professor. TA in the class of 5810 section 001. Today I'm recording this video for the reading assignment 10, and I choose the topic data mining and knowledge discovery in chemical processes, effective of alternative processing techniques. Coming to the summary, like the data mining and knowledge discovery, shortly we can say DMKD, have been used together to find meaningful information from the data. The DMKD has been found useful in the chemical industry to perform tasks such as fault detection, process control, process monitoring, and optimization. The DMKD process also involves selecting the appropriate method for every step, which are data cleaning, data sampling, scaling, dimensionality reduction, clustering analysis, and data visualization. For this purpose, a computational environment has been created to know how these methods impact DMKD in chemical data processing. Thus, simulated data and real-time industrial data are gathered to analyze the methods and their applications in the real-time scenario. Coming to the critical analysis, chemical process overview. In the chemical process industries, there are several factors that need to be taken care of, such as safety, efficiency, and responsibility towards the environment. When we are trying to interpret the data, there are many activities that rely on the industrial plant data sets, which are product scheduling, fault identification, root cause, and maintenance. The real challenges lies in the size of data set generated by the process and the speed with which it gets added. To work with this data set to know the overall state of process, a computational advancement for chemical process industrial application is done through the data mining and knowledge discovery. Coming to the data mining and knowledge discovery, DMKD, the implementation of DMKD involves several steps mentioned below. Firstly, it is the data collection. After collecting the data, we'll be doing the data cleaning. Post that, we'll be sampling the data. And the fourth step is scaling. Then the fifth step would be dimensionality reduction. And the sixth step would be clustering. And the seventh step would be knowledge discovery. This is how the implementation of DMKD involves. And these are all the 7 steps. And the main aim of the DMKD is to train a learning agent to find the patterns that were earlier unknown to a dataset. The learning agent, which is a model, can recognize these patterns and provide the exact information by performing 2 main tasks, which are the dimensionality reduction and clustering. And this is the steps: data collection, data cleaning, sampling, scaling, dimensionality reduction, clustering, and data visualization. The DMKD was built using a variety of data pre-processing, dimensionality reduction, clustering, and visualization methods to conduct research on 2 different chemical plants, which are simulated natural gas liquid plant and real pyrolysis reactor. Coming to the DMKD stages, data pre-processing. Data pre-processing is a step that is used to improve the quality of the data and is also has its own shortfall. For example, the outliers in the data, if they are not getting removed, would affect the estimates, confident regions, and other tests that are going to be performed on the data. Another issue is considering the scale of different variables, hence data pre-processing needs to be done carefully. Coming to the data cleaning and outlier removal. For smaller data sets, it is easy to remove the outliers, but when the size of the data set increases, it becomes difficult to remove them. There are 2 methods that can be used to detect outliers. They are Z-score and nearest neighbor, KNN. Coming to the Z-score value, if it is greater than or equals to +3 or -3, it indicates that they are outliers. And the K nearest neighbor is a 1050 algorithm to identify the anomalies in a data set. It identifies the outliers by examining the relationship among the neighborhood in data points. If the data point, in case it is farther from the neighbor, the higher chance is that it is an outlier. Coming to the sampling, in sampling, the proper data subset needs to be chosen that is well distributed and balanced. When we do not get the proper data subset, 2 approaches can be done: the oversampling and undersampling. Coming to the oversampling, we use data augmentation methods to generate new data samples, thus increases the data points. Undersampling, we don't have enough data points to bring to match the balanced data points. Coming to the scaling, it is important to consider the scaling for different variables instead of a single variable, which would rely on the relative magnitude with respect to other variables. Proper scaling has to be done as a different method. Models have requirements for different scales for the different variables available in the datasets. In scaling methods, there are 2 main activities, which are standardization, normalization. Coming to the standardization, in this the Gaussian distribution is considered for the data. The Z-score method is used. Normalization, in this we don't assume any distribution for the data, but we scale the data using estimators. Dimensionality reduction. The dimensionality reduction is the process of reducing the number of variables. This can be achieved using two methods. Matrix factorization, it is the most widely used method in the principal component analysis. In this method, the original dimensional space data is decomposed into two lower dimensional matrices. Then we apply an optimization algorithm to reduce the reconstruction error. Neighbor graphs. In this method, a mathematical graph is built from the original dimensional space data, which is a kind of connected graph between the variables. Then an algorithm is applied that reduces the reconstruction error. Clustering. Clustering is a process of dividing or partitioning data into groups. The clusters can be of two types: flat clusters, hierarchical clusters. Flat clusters are nothing but it will create all the clusters at the same time. Hierarchical clusters, it will create clusters one by one. The hierarchy are further divided into agglomerative and devised algorithms based on bottom-up and top-down methodologies. There are also methods for clustering: centroid-based clustering and destiny-based clustering. Coming to the centroid-based clustering, in this method, it assumes a distribution within the cluster and creates a new cluster around a point which is called the centroid following that the distribution. A density based clustering, in this method we do not assume any distribution or any centroid. It is the most powerful and the versatile method, and it generally works on well versed large data sets. Data visualization, for data visualization, self-organized map is used to visualize the high dimensional data. The SOM is also known as Pownell network, which is non-linear, ordered and used for smooth mapping of high dimensional data on the elements of low dimensional data. The SOM has been found useful for data pre-processing for the unlabeled industrial plant data, and also used to view the clusters within a dataset. The nature of SOM and its features are proved to be useful in various industrial processes such as processing, monitoring, and data visualization, etc. Data analysis environment. The fast manual data classification is a graphical user interface built using Python libraries. The method available in the libraries are used for easy manipulation of various methods such as the data pre-processing, clustering, dimensionality reduction, etc. These are the several data analysis methods available for each step of DMKD. For example, in the Fastman, for the performing sampling, we have data analysis methods such as the random sampling, KNN, etc. In the Fastman GUI, when we go through all the DMK steps from data cleaning to data visualization, we have the ability to go back to a step and change the data analysis method as well. Coming to the results. After studying the various DMKD steps, it has been analyzed for two case studies, which are simultaneous natural gas liquid plant and a real phosphor reactor. The normalization and the neighbor graphs for dimensionality reduction outperformed when compared to the matrix factorization method for dimensionality reduction. Coming to the conclusion, the DMKD methods have been found very useful in the chemical industry for several tasks. There are few limitations to it. On one of them is to navigate through various methods available for each DMKD steps and select the suitable one for a given use case. The data pre-processing and the data collection have been very time consuming. The dimensionality reduction and the clustering algorithms turning does have a considerable impact on responsibility and performance. Hence, knowledge of all these methods and the right selection of these methods can only pave the way to make the DMKD process streamlined in a chemical process industry. Questions? There are no questions to ask, Professor, because the steps which I have performed are understood clearly. And thank you for giving me the opportunity, Professor. Thank you, class.